Hi, this is Hayden Garner,
and Carolyn Mazuka. We're presenting enantiomers, diastereomers,
meso compounds, and constitutional isomers.
So enantiomers are basically mirror images of one another. In this molecule we got a cyclic hexane structure, an OH group, and a Cl group. So with an enantiomer, to draw one, what you do is basically there's two ways to do it. You can either flip the wedges of the structure. So in this first one, we will have a solid wedge on the OH and a dotted wedge on the Cl. And what you can see, that's an enantiomer because it's a mirror image. So if you were to flip this over on itself, it'll just create a superimposable image. The other way to draw an enantiomer structure is to flip it over itself. So then on the other side of the molecule, you'll both still have the same type of wedge as the original, but it'll just be on the other side of the structure. In this case, it's still an enantiomer because it's still a mirror image of itself. Next, we're going to talk about diastereomers. They are a lot like enantiomers in that you do flippings, except that they're not mirror images because you only flip one. So, the first way to draw it is you can keep one of them the same, and then the other one has to have the opposite wedge of what it does. So in this case, a Cl would change to a dotted wedge versus a solid. Or the other way to do it is you can't flip it over and do this because then you'd actually be making a different molecule. But you can choose to change the OH instead of the Cl. So you'd have an OH here with a solid wedge and the Cl with also a solid wedge. And if you look, this compound and this compound are enantiomers of one another because both the wedges have changed.
Mesocompounds or mesoisomers are compounds that show a plane of symmetry. When drawn through, you can see that here and here planes of symmetry can be noted, as well as in the bottom structure, a plane of symmetry can be seen here and here. So both, therefore, are mesocompounds. Constitutional isomers or structural isomers for C3H6O. Constitutional isomers have the exact same molecular formula, however, they are attached in different ways. As you will notice, I have 6 examples. First is 2-propanol. You will note that there are 3 carbons, 1, 2, 3, as well as the oxygen and the 6 hydrogens. The cyclopropanol also has the exact same. 3 carbons, 1, 2, 3, the oxygen and the 6 hydrogens. Then the propanol aldehyde, 1, 2, 3, the oxygen and 6 hydrogens. Again, you'll note that acetone has 1, 2, 3 carbon molecules, 1 oxygen, and 6 hydrogen. Again, the oxetane has 1, 2, 3 carbons, 1 oxygen, and 6 hydrogens. The propylene oxide has 1, 2, 3 carbons, 6 hydrogens, and 1 oxygen. These are all constitutional isomers because they have the same molecular formula, but they have different connectivity points within their specific structures.